Hello world, my name is Victor Engelmann, and in this video I'm going to show you how to build an extremely minimalistic Linux distribution. A very small distribution. It's only going to be, I think, 12 megabytes or so. And yeah, I've already created a video series on my channel about Linux from scratch, and I think that was, I don't remember exactly, I think around 10 hours. But yeah, the thing about Linux from scratch is that it's a complete Linux distribution with networking and C compilers and tool chains and everything. And yeah, today we will build a much smaller system that is really only supposed to give you a shell so you can navigate your file system and start programs and such. And yeah, to achieve that without all this overhead of a tool chain to create all the GNU utils and stuff like that, we will be using Busybox. So we will actually only build 2 packages. So that's really, really minimalistic. And yeah, then we will have a Linux kernel on the one hand. And yeah, I mean, Linux systems generally require a kernel and a root partition. You know, where the kernel finds its instructions, what to do on startup, and yeah, the programs and drivers to load. And yeah, so that's what we will have to do. We will have to build a kernel and create a root partition, but that root partition is mostly only containing Busybox. Okay, so yeah, what's Busybox? Maybe I should explain that. Well, Busybox is like a little program that can do a lot of stuff, like a program that can take something that's a normal instruction in a bash script, like echo here, and yeah, it can execute that. Okay, so Busybox is like a shell, but yeah, a normal shell would start a separate program called echo for that. Okay, but yeah, Busybox has all these commands built in, so so you don't have to build all the stuff around these tools. Okay, so yeah, let's dive right in. I will create 2 text files. Busybox X, like, you know, this typical ending for Linux distributions. Everything has to end with an X, and some temp sh. Okay, because I want to do this step by step, but in the end, so in this temp file I will always do the next step, but then I will put everything into this Busybox sh so that we will in the end have one big script that does all the building in one go. Okay, good. Start with the typical shebang. Okay. Now, yeah, as I said, we will need a kernel and a root partition, and on that root partition, we basically just want to have Busybox. So what we will need to do is we will need to download yeah, this kernel source code. So we will go to kernel.org, and here under protocol HTTP we can browse the pub directory, and in here we go to Linux, kernel, and yeah, I will go for a 5 point something kernel. And here we have a long list of kernel releases. Okay, 5.15.6 seems to be a very recent one. Let's see, XZ seems to be stronger compressed than GZ, so I will copy this link here. Okay. And we need Busybox. So we go to busybox.net, download source, and here we also have a long list of releases. And here 134.1 is the newest one. These two here are signatures. This is the one that the tar.bz is the one that we need to download. Okay. Yeah, of course we can pull out this version here. Okay, and put this in a variable. Now, yeah, here this v5.x, yeah, this 5 point something is the beginning of this kernel version. So we basically need to extract this major version here. And yeah, that's a typical use case for Z. So we take the leading digits 1 to 9 star and capture that in a capture group, followed by something that isn't a number. So if the number would happen to be 10 or so, I don't want to capture only the 1, I want to capture the full everything until the first character that isn't a number, okay? Okay, and then after that anything can happen, I don't care. But I'm taking digits until we encounter the first non-digit here, okay? And that's what we enforce there. Okay, and we map that to the first capture group, so the stuff that we've captured here. Okay. Yeah, maybe let's try this to make sure that it works. And you see it indeed takes the first number. Okay. So this seems to work, and then we can replace this here with kernel major, and now we can just change the version that we want to have up here, and everything else should just work without any further actions on our side. Okay, so just changing the number up here is then supposed to just build the same system with a different version of the kernel and or the Busybox. Okay, good. Now I will create a directory src, and we will change directory into that so that we download the stuff into that directory. Okay, and then we will unpack the archives, extract file, and extract file Busybox. Okay, so I will group that. So this is the stuff for the kernel, and down here the stuff for Busybox. Okay, so when we unpack this Linux archive, then we will get a directory called Linux with the kernel version. We can cd into that. Okay, and yeah, when we are in that directory, we will then need to build the kernel. And yeah, I've already made a video about building the kernel, so I'm not gonna go very deep into that here. I'm just gonna say make dev config, so we get the default configuration, and then make with J8. But in case that fails, I want to exit the script. Okay. But let's start by doing this, downloading the kernel and compiling it. Okay. So okay, so we have temp.sh, and this was output into temp.sh, right? Yeah, let's run this. Okay, we're downloading the kernel source. That's amazingly fast. I think it's unpacking now. Now it's creating the default configuration. And now it's compiling the kernel, and yeah, this can take a while. Okay, it's finished building the Linux kernel. And at this point, I will throw all this stuff over here into the other shell script, because yeah, the kernel is now done. I will throw that out of this temp script. And yeah, now let's start building Busybox. There you have the same situation. When you unpack it, you get a directory with that same name. And in that directory, you can then build Busybox. And yeah, Busybox has a similar build system as the Linux kernel, so you can just say make dev config also. Okay. And yeah, I will execute this now, and then we will talk about this some more. Okay, so now it has created this default configuration file. Okay, so now we have this default configuration file, but we now need to talk about Busybox a bit more, because yeah, of course we want to build Busybox, but that's not so simple in my case here. And since we've already downloaded and extracted the source code, I will throw this out here. Okay. Yeah, now we need to talk about how to build Busybox, because that's not as straightforward as I would like it to be, at least not on Manjaro. You know, I'm running a Manjaro system here. And the problem is that our final system is not gonna have an LDD, I think. So it's not gonna have any facility to load dynamic link libraries, DLLs, as they would be called in Windows, or shared objects, as they are called in the Unix world. Because of that, we need to tell Busybox to create a static build. So the libraries that you would normally have as separate files and that it would load on runtime, they need to be put into the executable binary. Okay, so that they don't have to be loaded dynamically. Okay. So we will need to do something called a static build, and you can, just like in a Linux build, you can also do make menu config. Okay. And there's you get this menu, very similar to the Linux menu config. And here in the settings, a bit further down, you can say build static binary. Okay, but I want this to be a script, right? So I don't want to go through this graphical menu here. So what you can do instead is you can go into the file .config, and in here you have a setting called config static, which is not set, and we can set it to equals yes. Okay. That would be one way to do it, but that's still manual work, and I want this to run through without any user interaction. So what we can do now is, again with Z, edit the file .config and replace a line that contains config static. So we take the entire line and replace that with config static equals yes. Okay. Good. So this changes the configuration to a static build. And now we would be able to run make, again with J8, and if that fails, exit. Okay. But here we have another problem, because again, this is a Manjaro system, and Manjaro is based on Arch Linux. And I've gone through a lot of online discussions about this topic. A lot of people have problems with that, and the maintainers are not very helpful on it. So they just say, "Oh, just use Musel," and it's not really obvious what that means. So I spent I don't know, half a day yesterday figuring out how to just use Musel here. So what you need to do is you need to install the packages Musel and kernel -headers -musel. Okay, I've already installed them, so nothing is going to happen here on my machine. But yeah, you need to install these packages. I think on Debian-based systems this is probably not necessary. You know, this on Debian-based systems and I don't know, Fedora. I think most other Linux distributions will just succeed in building with make J8. But the problem on Manjaro systems is that the library libcrypt is there's just no static version of that in a default installation of Manjaro, and I wasn't really able to build one easily. So this whole approach with Musel was just simpler. So that's what I then ended up doing. And yeah, now what is Musel? Musel is an entirely separate tool chain. So instead of GCC, we will now compile with Musel GCC. Okay. So that will then build our Busybox. Okay. Good. Yeah, we already did this make dev config, so gonna comment this out for now. Yeah, let's run this. I don't know why it's asking me about static libgcc. I will just say yes, because as I said, we want to build a static build, and this sounds like it's related, so I will say yes. I don't know why it's asking me this, but okay. Okay, now it's done building this. And interestingly, it's saying here that libcrypt isn't even needed, so I really don't know what all the fuss was about, but okay. I think I see why it's asked me about this setting for static libgcc. It seems that my Z script has also changed this variable, possibly. Yeah, maybe say something other than an underscore after that. Okay, so this builds Busybox. Okay, now okay, so now we have built the kernel, we have built Busybox. So now let's take these two things and put them together into a working Linux system, okay? So so Busybox is built. So what we need to do now is we need to pull the compiled kernel from the source directory. okay, this is the kernel, and we will copy that here into the root directory. Okay. So now we have the kernel here, and yeah, the other thing that we need, as I said, is a root drive. So and we will do that as an initial RAM drive. So what I will do now is create a directory. init.rd, change directory into it, and yeah, in there we will create 4 directories, bin, dev, proc, and sys. These are really standard directories that you will find in almost all Linux systems. Bin is where we will put our Busybox binary and do some magic with it. Yeah, dev is for the device files, proc is for the process files, and sys is for the interaction with the kernel. These are these typical virtual file systems that you will find on almost all Linux systems these days. Okay, good. So we create these directories and then move into the directory bin. Okay, and now we will build this bin directory. How do we build that? Well, first of all, we will copy Busybox here. Okay. Okay. So in here, in the source directory Busybox, there's this program Busybox here, and that's the compiled binary that we need to take, and we put this now into this bin directory. Okay. So now we have that. Yeah, one interesting thing that Busybox does, I need to explain that, I think. So as I've shown you, Busybox can do stuff like execute normal shell commands, right? But Busybox is a bit smarter than that, because you don't have to pass a program name as a parameter. Busybox will also examine its argv0, which is its own file name. Okay, so if you renamed Busybox to echo, for example, it would always do echo. And you can use that with a symbolic link to bin Busybox, and yeah, let's call it echo. Okay, now we have a program echo here that we can use, echo hello world, and internally that's Busybox, but Busybox can see, hey, you've renamed me to echo, so you want me to behave as echo. Okay, good. So and now we will use that to our advantage, because yeah, the next thing that Busybox does is with Busybox -- list, it gives you a list of all the things that it can pretend to be. Okay, there's a lot of stuff here. Okay, I've seen there's grep, hdparm, du, dir name, a lot of programs that it can pretend to be. And yeah, this is what we will now do when we go to the directory bin. In here, we run busybox --list, okay, and then iterate through all these programs that it can pretend to be. Okay, and yeah, set these symlinks for these programs to Busybox. So ln-s bin Busybox proc, okay. So at one point this list will contain, for example, echo, then proc will be set to echo, and then we create a symlink called echo to bin Busybox. You know, the stuff that we have just done up here. Yeah, basically what we did here, right? We created the symlink called echo to Busybox, and this is exactly what we are doing now here. Okay, let's run this. Good. Now if we look into this initrd bin, you see we have now all these programs, and we could now tell them to, and we could now use them as these programs, although they are really just symlinks to Busybox. Okay, now after we've created this bin directory, we are almost done. We still need to tell the kernel what to do on startup, and yeah, we can do that by creating a script called init, for example. There are other legal names that you could use, like sbin init, or Linux RC would be legal, but yeah, I will create a file called init here. Put a shebang in there. And yeah, on when we boot, what do we need to do? We need to mount these virtual file systems that we've talked about, you know, dev proc and sys. Okay, here we mount sys. Then we mount proc. Okay. Yeah, the next line, I don't think that's necessary, but it was in the code that I've seen. Syscontrol -w kernel.print_k, and this sets some settings which tell the kernel different log levels. Okay, 2417. I don't care much about that. Once we've done this, we are basically done booting. So we could now do a clear to clear the screen and then run bin sh. Okay, so at this point we then get a shell. Okay, and yeah, then we can use the shell. Then we can print the a directory listing, change directories, stuff like that. Yeah. For my taste, we don't really need this clear here, so I will throw that out. But anyhow, now once we've done that, we need to set. I mean, it's not necessary, I think, to give all files the permission 777. I mean, that's read, write, execute bits for all users. Our system doesn't even have users, I think, so I don't think that really matters, but I will do it anyhow. And yeah, once we've done this, we are kind of done. So we have all the files that we need, and then we can take all these files by using find on the current directory that finds all files in that directory and pass them to cpio. -o is for creating a file with format new C, and write that to the file init.rd.image. Okay. Yeah, this looks good. This output here with a number of blocks, that's the output of CPIO, and yeah, if that isn't 0 or 1 or something like that, it looks as if it has found a lot of things. So yeah, that looked like it's like it should work. I will move this over here now. And let's see, we now have bz image is the kernel, and init.rd image is our root drive. So what we can do now is we can now run qemu, the virtual machine qemu, with parameters -kernel bz image and -init.rd init.rd.image. Okay, let's try this. Oops, I made a typo. And look at that, it's booting. Okay, so it's a bit complaining here, but that's not really bad. We still can now look at the directory listing, change directory, look at the directory listing. Echo hello world. Create a text file, foo.txt. Cat it to the standard output. Edit it with V. Okay, now I don't know how to exit it. Anyhow, let's run it again. one thing that I want to mention is that when you press Ctrl D or type exit, so you end this shell. Linux doesn't expect your main program to end like that, okay? So you're getting a kernel panic here because attempted to kill init. Yeah, that's not supposed to happen. So something that I would do is to put another line behind this bin sh power off -f, okay? And yeah, if you do that, then exiting the shell will then just terminate the whole virtual machine. Okay, or if you're running this on actual hardware, then it will turn the hardware off. Okay, good. And yeah, that's basically all that we had to do. You know, we have a running Busybox-based system now, and I find that really awesome. It's so little work. I mean, look at how little code this is. It's 63 lines and a lot of empty lines in between. And it's creating something that at least looks and feels like a Linux system. Okay, I will put that at the end also. One more thing that I want to mention is when you run QEMU like that, you know, you get this QEMU window, but yeah, maybe you don't like that. Okay, what you can do instead is you can say no graphic. Then you don't get this window. But yeah, if you don't get this window, how do you know what the kernel is doing? And yeah, what you can do is you can tell the kernel through a command line switch that you want it to use the serial interface as console. Okay, and yeah, the serial interface is taken by QEMU, and it's it communicates with standard in and standard out. So if you do it like this, you don't get the window. You see everything in your terminal directly. Okay, here, as you can see, this was all the stuff that you've seen in the window before, and now here bin sh is a bit complaining, but yeah, here you now have bin dev proc root and this, and the init program, and yeah, all the stuff that we did before, you know. So yeah, that's I think that's pretty cool. Let me show you one more time. When you run this, and you know, I haven't updated the init.rd, so this line isn't in this init file. Okay, so if I end this shell now, I get the kernel panic again, and yeah, now this this shell window is now stuck, and to make it unstuck, I would just kill all qemu-system-x86-64, bam, and you see now it's gone. And yeah, this is how you can unfreeze your QEMU when it's running directly on your shell and it's run into a kernel panic or something. Okay, yeah, whatever. I think this is really cool, and I like this a lot. I think it gives you an even better insight into how Linux works and how Linux systems in general work. So yeah, if you like this video, like it, share it, subscribe, and see you next time.